All right, so for this week, we are going to talk about the mole-volume relationship. So we're going to add an island basically to our metaphor. So our question today is, what is the volume of a gas at STP, which means standard temperature and pressure? And we will talk about that in just 1 second. So Avogadros' hypothesis states that if you have equal volumes of gases, they're at the same temperature and pressure, then they're going to have the same number of particles. So basically, if you have any gas, it's at the same temperature and pressure, you're going to have 6.02 times 10 to the 23rd particles, no matter what gas you're talking about. The volume of a gas varies with temperature and pressure, and so that's why we're always going to be talking about a gas at standard temperature and pressure, just to have like a baseline for it. So STP means your temperature is 0 degrees Celsius, your pressure, and you can measure pressure in 2 different units. You can measure pressure as 101.3 kilopascals or 1 atmosphere. Okay, so just a little background on units. So a unit of pressure is a kilopascal. So any gas you're talking about, nitrogen gas, oxygen gas, if you have 1 mole of that gas and it is at standard temperature and pressure, then you have 6.02 times 10 to the 23rd particles, no matter what gas you're talking about. So it's a nice standard. So 22.4 liters is called the molar volume of a gas. And that's going to be our conversion unit. If you want the volume of a gas and you want to convert it, you're going to use the 22.4 liters for every mole. If you have 1 mole of a gas at standard temperature and pressure, it's going to occupy a space of 22.4 liters. So let's just kind of look at our island metaphor here. We talked about gram island, mole island, and the representative island. And in order to get from one island to the next, you have to go over a bridge. So if you wanted to go from the representative island all the way over to the gram island, you can't skip the middle. You have to go to mole island first, because remember that sea serpent is out there to get you. So you have to use bridges in order to go from one end to the other end. But what we're going to do here is we're going to add another island. And this is called volume island. And remember, we said if you have 1 mole of any gas at standard temperature and pressure, it's going to occupy a space of 22.4 liters. So you have to have your bridge. It has to be at standard temperature and pressure, and you're going to use the conversion unit of 22.4 liters for every mole. Let's go ahead and put this into practice. Suppose you have 0.375 moles of oxygen gas, but you want to know what is the volume of that gas. You always start with what they tell you. They said we have 0.37 moles. But I don't want to be in moles. I want to be in volume. And I put up a simplified chart up in that right-hand corner there. So you can see at the very bottom, it says number of liters. And then you can have the number of moles. That's our central island. You have the gram island and you have the representative particle island. We are in moles. So from moles and then to get to volume, you're going to use the conversion unit of 22.4 liters per mole. That's how we convert to volume. So we're just going to make sure and put that in there. Moles are on the bottom, so it cancels out. 22.4 liters is on the top. And you get to 8.40 liters. So that's how much space that gas is going to take up if you have 0.375 moles of that gas. Another example talking about sulfur dioxide. This is a gas produced by burning coal. It is an air pollutant. It causes acid rain. So they want us to determine the volume of 0.60 moles of sulfur dioxide, which is at STP. We always start with what they give us. They said we have 0.60 moles of sulfur dioxide, but they want us to go to volume. And in order to go to volume, we're going to use our conversion unit of 22.4 liters per mole. We want to make sure that moles are on the bottom so it cancels out. 22.4 liters is on the top. Moles cancel, and we're left with 13 liters of sulfur dioxide. One of the cool things about this volume conversion is that we can actually go from density to molar mass using the same conversion. And let me tell you what that means. So when you're doing density, it's grams per liter. And when you're dealing with molar mass, it's grams per mole. So let's look at this example. We have 1.964 grams per liter. Want to make sure that grams is on top and liters is on the bottom. This is a multi-dimensional analysis problem that you might vaguely remember from a few months ago. So we're in grams per liter, but we want to be in molar mass. It says, what is the molar mass of the compound? We can simply use our little conversion unit of 22.4 liters per mole. That cancels out our liters, and it leaves us with 44 grams per mole. Because that volume unit cancels out the liters, it's an easy way to convert back and forth between density and molar mass. So that's pretty cool. Let's do another one. Remember, density is grams per liter, molar mass is grams per mole. We usually just get the molar mass by looking at the periodic table. So it asks us, what is the density of neon gas at STP? Well, they didn't give us a number here. So we need to figure out what's the molar mass of neon. Because remember, we got to start with something. The molar mass of neon, if we look at the periodic table, is 20.18 grams per mole. That's what we can start with. 20.18 grams per 1 mole. We're going to put grams on top, moles on the bottom. But we don't want to be in molar mass, we want to be in density. Density is grams per liter. So we can use our standard temperature and pressure to kind of switch between units here. We are going to put mole on the top because we want it to cancel out. And we're going to put 22.4 liters on the bottom. If you look at how we set this up, our moles cancel out and we're just left with grams per liter. And that's our units for density. In your calculator, you would put 20.18 divided by 22.4, and you're going to come up with 0.9009 grams per liter. Pretty quick and efficient way to switch between units. One more example. We're going to look at xenon here. It says, what is the density of xenon gas at standard temperature and pressure? They didn't give us a number, which means we're going to have to look at the periodic table and figure out, well, what is the molar mass of xenon? Because in order to switch between density and molar mass, we need at least one number to go on. Molar mass is pretty easy to look at. Look at the periodic table, you'll see that it's 131.30 grams per mole. We're going to set that up with grams on top, moles on the bottom. We don't want to deal with moles, we want to go over to liters. So for every 1 mole, you have 22.4 liters of a gas. Our moles cancel out and we're left with 5.86 grams per liter. I'm going to give you a very simple worksheet to work on. It's the only thing we're going to do this week. I really want you guys to focus on trying to make sure that the units cancel out, that you want to cancel out, the setup of your problem, and please just email me. I can FaceTime with you. I can do a Zoom conference with you if you need to. I'm here to help you guys in any way possible. So hope you guys have a good week, and I'll talk to you soon. Thanks.